Welcome to this course on Elements of Mechanical Engineering. In this lecture, we are going to study the introduction and classification of boilers. So in this video, we are in the second module of the course Elements of Mechanical Engineering, where we are going to study the basic working of boiler. And also we are going to see what are the different types of boilers available in the industries and what are the advantages and disadvantages of using each one of them. First, let us understand what is a boiler and how a boiler will help us in generating a particular work. Generally, the definition of a boiler goes like this: it is a closed vessel in which the water under pressure is transferred into steam. So, in the picture, we can see a blue colored tank is there. This tank is known as a boiler. Boiler is a closed cylindrical structure in which we can boil the water and this water can be converted into steam. Now what happens? When we want to convert the water into steam, we have to heat the vessel. The entire vessel has to be heated. Now while heating, the pressure inside the cylinder will increase. This increase in the pressure has to be withstood by the vessel or the container. Now, in order to make the vessel or the boiler tank able to withstand the pressure that is generated during the heating of water, so there is a separate course for this, which is called plates and shells. So it is directly related to the design of the boiler body or the boiler shell, by which we can design it for withstanding high pressures. So when we take the basic definition of the boiler is a vessel in which water is converted into steam with high pressure. Now the function of a boiler is to transfer heat to the water in most efficient manner. We will get a doubt like, we want steam. I have to convert water into steam. Now we know water is in liquid form where it can be collected in a particular tank, whereas steam is in the gaseous form where it cannot be withholded. So it needs a container which is closed for holding the steam. Now, what happens is, when the water is converted into steam, the steam has to be holded and it has to be inside a container which is closed, and it can be taken from the tank to some other place where it can be used efficiently. Now, the boiler has to do two main things. One thing, it has to supply heat to the water, and it has to hold the steam that is generated safely. It should not leak the steam, so that the steam whenever the steam leaks from the tank, it is of no use. So the boiler tank should be designed in such a way that it has to supply the heat as well as it has the ability to hold the steam inside. Now, let us see. A boiler must be designed to absorb maximum amount of heat release in the process of combustion. So, not only the boiler tank having the capacity of holding the steam, it should also have the capacity to supply the heat which is generated during the combustion. Whenever there is a combustion, heat is generated. This heat is directly supplied to the water, and this water is again converted into steam. Now we have many applications where we can use steam, like in thermal power plants or for cooking, or many other applications are there in chemical industry or fertilizers industry. In many places, boilers will be used. So the boiler body should be designed in such a way, it has to withstand the high pressure, it has to withstand high temperature, and it has to supply the heat that is generated from combustion to the water in an efficient manner. Okay, So this is all the basic definition of boiler. Okay. Now let us see what are the applications of boilers. Where do we use boilers? So back in the olden times, where the human being first invented the fire, he started cooking, and after that he started boiling water, and in which he put some vegetables and or put some meat and he cooked it. So that is when the boiling of water started. But nowadays, the steam generated from the water is utilized in a very efficient manner. Like it can be used to run thermal power plants, or it can be used to heat the rooms, or it can be used in many industrial processes. Now, let us see some of the applications where the steam generated can be used. First one is power generation. We know there are some thermal power plants in India and all around the world. These thermal power plants were able to generate electricity with the help of the steam only. The two main raw products that are required for the power generation in thermal power plants are coal and water. Now, what happens is we will take the water in a closed container, that is boiler. We will supply heat that is generated from the combustion of coal, and this heat is taken by the water and it is boiled up to its boiling point, where it will be converted into steam. Now this steam is made to, usually the pressure of the steam generated will be very high. So this high pressure steam will be made to touch the turbine blades inside the turbine, where the turbine will rotate. Now the rotation motion of the turbine will be converted into the rotation of the electric generator, where it can produce electricity. So this is the first application of a boiler in power generation, where mechanical or electrical power may be generated by expanding the steam in the engine or steam turbine. So in olden days, we used to see the steam locomotive engines, like for railway applications we used, where we will use some water. This water will be boiled with the help of coal combustion, and the steam is generated, and the steam engines runs on the same principle as the cylinder piston arrangement, where the steam will be made to enter into a, the combustion of the coal will be done in an open chamber, where the heat will be supplied to the water. The water is converted into steam. The steam is made to enter into a piston cylinder arrangement, where the piston will move to and fro. When the steam is entering into the piston will move in one direction. When the steam is removed from the cylinder, the piston will move in opposite direction. Now this to and fro motion is converted into some kind of rotary motion, where the engine will be moving. So this is one application where we can use the steam in locomotives and power generation. And second application is heating. The steam can be used for heating residential and industrial buildings in cold weather and for producing hot water. So boilers are also used to heat the rooms, where we can take hot water, and the steam generated from this can be supplied to a room. When the weather is very cold, the room can be kept hot enough to survive. And also in industries, where large amount of machineries will work, where the temperatures are very high. So it will be very discomfort for the people who are working. So in those industries, we have to use steam, okay, where we can use this for heating the rooms or cooling the rooms in many applications, so that we can make the human beings or personals get comfort while working in that kind of situations. So we have to take the example of a cold working area, like a cold storage. So there we have to heat the room of the operator, where he does not get very cold because of the temperature of the cold storage. So this is the second application where we can use the boilers for heating. And the third application is industrial processes. So steam can also be used for industrial processes such as sizing and bleaching. So these are some of the applications in industry where hot steam is required. So for the production of hot steam, we have to use the boilers. In textile industries also, steam is used for the production of cloth and other applications like sugar mills, cement industry, agricultural industry and chemical industries. So these are some of the industries where we have to use steam in any manner, like depending on the type of application, we have to use the steam in different way. However, we have to produce this steam in order to use in all these industries. So in almost all industries which are production related or agricultural related, the steam is very important. So that is why we have to study the working of a boiler which produces steam in this lecture or in this course elements of mechanical engineering, which is related to mechanical industries. Now in the picture, in the slide, we can see this is a thermal power plant where we have a lot of chimneys from where a lot of steam is being generated. We have said in the previous slide that the production of electricity will be made with the help of coal and water. Now what happens? When in a thermal power plant, we have to take the coal, we have to make the coal combustion, and the heat generated from the combustion of the coal will be supplied to the water, and this water will be converted into steam. So in an entire thermal power plant, we can see this is the basic structure or basic area, which is where the electricity or generators are placed. Okay, so that is where the generators are placed and steam turbines will be placed. And when we see the chimneys, we have two types of chimneys here. These are long cylindrical chimneys and these are wide, shorter chimneys. Both of them are being generated some kind of smoke or steam. Now, what is the difference between these two? Well, we'll try to understand what is the difference between these two types of chimneys. So, the first, these long thin chimneys are the ones they are producing the combustion gases that are released during the combustion of the fuel, that is coal. So, when the coal is burned, heat is generated and some gases are released. So, that gases are sent out into the atmosphere after being processed in many stages. And so, this is the gases that are emitted from coal. Whereas, these two are other type of chimneys where they will cool down the steam that is generated, and this steam can be converted into water by cooling, and this water can be reused for the next cycle. So first of all, we have coal which is burnt and heat is generated. This heat is supplied to water and this water is converted into steam, and the steam is cooled down, and again this steam which is converted into water and it is sent back to the boiler and it is heated again. So this process continuously goes on because when we are running a thermal power plant, we have to see that the temperature we are using two raw materials. One is coal and the second one is the water. So these are the two raw materials which are used in thermal industry, in thermal power plant. So anyway, the coal will be exhausted after combustion, but the water which is converted to steam, the steam can be cooled down and can be reused. So that is why we are, because the water is very scarce on the planet Earth, we have a lot of water, but still we have to save and protect the water bodies. So that is why here the steam is again cooled down and converted into water for reuse. So these are some of the applications of boilers. Now let us see what is the classification of boilers. There are different types of boilers are there available in the market. depending on the particular application, we have to choose a particular type of boiler. Let us see the first kind of boilers according to the contents in the tube. So depending on the content, we have to choose two types of boilers are there. So first one is fire tube boiler and second one is water tube boiler. So let us see what is the difference between these two. We'll try to understand very fastly. Fire tube boiler. So in a closed container, I have coal here. So this is coal. When I try to burn the coal, it will produce some heat. Now what happens? I will arrange a tank over here. Inside this tank, water is there. Okay, so this is all water. Now what happens is, I will put some tubes. Here I will put some tubes which has opening at the bottom. So I have tubes. Okay, here whatever the hot gases that are being generated during the combustion of the coal will be entered into the hot tubes. So these are called fire tubes because they have hot air inside them. They are called as fire tubes. Now what happens is, whatever the heat gases that are generated while the combustion happens, they enter into these hot tubes, and because these fire tubes are placed inside the water, the temperature of the hot gases will be transferred to the water and the water will be converted into steam. So this is the first kind, fire tube boiler. And in water tube, it happens in reverse. In water tube, we have a set of tubes that are aligned like this. So what happens is, when the water will be flowing into this tube. So water is flowing into the tube and we have coal here. Okay, so this is coal. So when we burn the coal, the heat is generated, then the heat will be supplied or the heat will be touching the outer surface of these tube. Now what happens is, when the water is flowing through this, and the water will enter here and it will come out on the other side. Okay, on the other side we'll get steam. So the hot gases that are generated while the combustion, they will be supplied to the surface of this pipe. So inside the pipe we have water. So whenever the water is subjected to hot gases, the water will be boiled and it will be converted into steam. Now this steam will be collected on the other side of the boiler. Now this tube is called water tube and the boiler is called as water tube boiler. So this is the basic difference between fire tube and water tube boiler. So this is the first classification. Let us see the next classification according to the position of the furnace. So according to the furnace, there are two types. One is internally fired boiler and externally fired boiler. In this example, we have a diagram here. We can see the coal is made to burn inside a closed chamber. Then it is called internally fired boiler. If it is open to atmosphere, so the chamber is open to atmosphere where we are combusting the coal, then it is called externally fired boiler. That is the simple difference between these two. So internally fired means the coal is made to burn in a closed chamber. When it is open to atmosphere, it is called externally fired boiler. And third type of classification is according to the axis of the furnace. So there are different types of, so depending on the axis in which the boiler is mounted. So it has three types: vertical boiler, horizontal boiler and inclined boiler, depending on the inclination or depending on the orientation of the tank. Okay, so simply we can understand. So if this is a boiler, if the boiler tank is like this, so inside this we have water and here we will take coal. So this is a simple vertical boiler. We'll study in the coming slides. So this is a vertical boiler. If the tank of the boiler is in the horizontal direction, okay, so here we will supply heat. So this is a horizontal boiler, and sometimes this horizontal boiler will be kept inclinedly so that to increase the surface area for the heating process. So that is inclined boiler. So these are the different orientations of the boiler tank. Okay, vertical boiler, inclined, and horizontal boiler. And next, we'll see the other type of classification according to the number of tubes, depending on the number of tubes also. So in the previous slide, we have seen there are tubes here, fire tube and water tube boilers. We have seen tubes. So what happens is, when we have more than one tube, it is called multi-tube boiler. If it is a single tube boiler, it is called, so there is only one tube inside the boiler which conducts the heat from hot gases to the water. Then it is called a single tube boiler. If it is more than one tube, then it is called multi-tube boiler. Then according to the method of circulation of water. So we have seen in the previous slide that there is a tube here. So inside the tube, we have to make the water flow. Okay, we have to make the water flow through this tube in order to make steam. Okay, we will supply some heat. When the water is flowing through the tube, when on the one side we will make the water to enter into the tube, on the other side we can collect steam. So what happens is, different types of situations will be there where we have to make the water flow into the tube forcefully. Then it is called forced circulation boiler. So in forced circulation boiler, we have to use a separate pump here. We have to use a pump which will pump the water into the tube so that it will flow through the tube for heating. And in natural circulation boiler, we will use gravity for the circulation of the water inside the boiler, inside the tube. Okay, so then that is called a natural circulation boiler, where we will use gravity for the movement of the water inside the boiler. Okay, when we use a separate water pump, then it is called forced circulation boiler. Next, sixth type, according to the use. Stationary boilers are there, mobile boilers are there. Stationary boilers are nothing but the boiler which is mounted or installed in a particular area or in an industry where it is not movable. It is stable and it will be working at the same place only. Whereas mobile boilers are nothing but they can be moved from one place to another place, like ready-made concrete mix trucks will be there. Similarly, we have mobile boilers where they can be moved from one place to another place and they can be used in a particular place. Okay. And according to the pressure, there are two types of boilers, that is high pressure boiler and the low pressure boilers. So when the pressure is very high inside the boiler, which means the efficiency is very high, these type of boilers are called high pressure boilers. This kind of boilers will be used in thermal power plant. And the low pressure boilers are nothing but the boilers which have low pressure. These are generally used where we have to heat a particular room, or they are used for small applications like cooking, etc. Okay, we will use steam for cooking also. Now let us see. So this is a simple vertical boiler. Now we'll try to understand how this simple vertical boiler will work. And in the next slide, we will see what are the features of this boiler also. First, we will try to understand how this simple vertical boiler will work. In the first picture, we can see here there is a chamber inside which we have taken the coal or any fuel, which will be combusted, and this combustion will create some heat. Okay. Now, here we can see in this area we have water. So all the dotted lines here, so this dotted lines indicates the presence of water. Okay. Now only this part is water. So this is water. So if we observe carefully, this container or the water tube inside the boiler is inclined. It is not horizontal. You can see this is inclined. Okay. So we'll try to understand why this tube is kept inclined, why not vertical or why not horizontal. So what happens is, whenever we have a combustion of the coal taking place at the bottom here combustion will take place. The heat will be supplied to this tube, and the water inside the tube will be heated, and it is converted into steam. Now the steam will be converted at this point. Okay, we have a separate opening here. This is all steam. Okay. Now whatever the hot gases they are there, they will be entered into the atmosphere through this chimney. Okay. Now from this working, we can simply understand this is a water tube boiler, because the water is flowing inside a closed tube, which is water tube boiler. Okay. Now we'll try to understand the process. Here the coal will be combusted. This heat will be supplied to this water tube, and the water inside this tube will be converted into steam, and it is collected through separate openings on the other side. And whatever the gases, hot gases coming from the hot gases and smoke, so they will be exited into the atmosphere through this chimney. Okay, so this part is called steam. This is all steam. So it will be collected, and it will be sent to the particular application. In the right side, we can see an actual simple vertical boiler. So this is the actual boiler, which is closed. We cannot see what is happening inside. We can see only some kind of attachments or mountings that are present on this. From this, we can understand how the boiler is being working. Okay, so this part can be the place where the coal will be combusted, and we have a opening here to collect the water. That is when the whole boiler is being maintained or some kind of repair happens, we have to remove the water. So then we will use this. This is a water exit, and this is water pump. We have connected a pump here. So we can see here, this is a pump. Electric motor is connected. This electric motor will be forcefully sending the water into the tube. Okay. Why we have to send forcefully? Because this is a forced boiler, forced convection boiler, because we have to make the water boil with the help of a pump. Okay. And we have some other components here. There are a lot of pressure gauges, some kind of attachments here. And this is a water level indicator, which will indicate how much level the water is present inside the boiler. And it also indicates how much steam has been generated inside. So these pressure gauges are there, which will indicate the pressure of the steam that is generated inside the cylinder. Okay. So this is the general diagram. This is for understanding the working. Now we'll see what are the features of this simple vertical boiler. So far we have understood that the simple vertical boiler is a water tube boiler, and forced convection is done here. That means the water is forced into the tube with the help of a pump. And this is also internally fired boiler. Okay, based on the previous classifications we have studied. So this is the classification. This is a water tube, forced convection, and internally fired boiler. Now let us see some of the features of this simple vertical boiler. The first one is vertical. The entire thing is made vertical. We have coal burner, on which we have water container, above which we have a chimney. Okay, and this is also a single tube. So in the picture we can see we have a single tube. This entire thing is placed in a single tube only. Okay, and we have a water container, that is also a single tube. Okay, we have only one tube is there. And then internally fired, we have the combustion that is made inside the closed chamber. So it is a internally fired boiler. And then we have natural circulation. So we have natural circulation here. The water will be circulated naturally. And then water tube boiler. So the water is present inside the boiler. So that is why it is called a water tube boiler. And then this is a low pressure boiler, where we will get very low pressure when compared to other boilers. And then maximum steam pressure that can be developed by this boiler is 10 bar. Okay, we can generate a pressure of about 10 bars only. Above that, we cannot use this boiler. So this boiler has the capacity of producing a steam of 2500 kilograms per hour. Per 1 hour, it can produce 2500 kilograms of steam. So if we want more quantity, we have to use other types of boilers. Now let us see some more features of this simple vertical boiler. So it produces a steam at low pressure in small quantities. So this is a simple boiler where we can get only very less quantity of steam at very low pressure. Okay, so that is one of the feature of this boiler, and it uses for power generation at places where the space is limited. So this kind of boilers can be used at some places where the space is very limited. So we can say that this is a compact, very small sized boiler. And the 11th point is it consists of a cylindrical shell. We know that this is a structure that is made out of a cylindrical shell inside which we have a water tube, and also we have place for combustion of the coal. And then 5 boxes fitted with one or more inclined cross tubes. Now in the previous slide we have said that we will discuss why this boiler's water tube is kept inclined. Now see here, this is inclined, this is not flat, this is inclined, inside which we have water. Okay, now this angle, what are the angle that is given to this boiler tube, water tube? So this is indicating the natural circulation. So when the tube is kept inclined, we can make the water flow on its own. There is no need to use any external type of pumps for circulation. So to make it naturally movable, natural circulation, we have kept the water tube at an inclination. Now see here, inclined cross tubes will increase the heating surface area also. So whenever the tube is inclined, we can increase the surface area. When the tube is horizontal, this is the actual length. This is L. When the tube is inclined, we have to increase the length so that it will reach the other side of the other shell of the cylinder. So here we will have more length. Some extra length has to be given to the water tube. Okay, so this will increase the surface area, so that with increasing the surface area, we can increase the heating. We can heat the water more efficiently. And then a manhole is provided at the top to clean the boiler. So at the top of the boiler, we will have an opening where a human being can enter into the boiler and he can clean the entire surface. So from this we can understand that the boiler is a very big structure where human beings or persons can enter into the inside of the boiler and he can clean the parts, and it can be easily transported. So this boiler is very simple, because of which it can be easily transported from one place to another place, and it can be installed at some place for the production of steam. Now this is all for this class, and we'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.